Good morning, afternoon, or evening. Welcome to the six-man session. I'm Bob Hinden, this is Louis Tron, the chairs of six-man. I think we have enough people to get started. Next slide, Oli. So please note the note well. I'm sure you've all memorized this by now, but you need to follow all of the IETF processes and policies and procedures, and it's almost as much stuff as all the technical work. Next slide. Administrivia, the Jabber room. I just used the Meet Echo one. Here's the links and the minutes. Many thanks to Shu Ping and Barbara for taking minutes. They've done it in several past meetings. Do a great job. Thank you very much. We don't have an official Jabber scribe. Sort of doesn't seem that it's necessary. And this is the link to find the presentations. And I think there's also a link in Meet Echo. Next slide. And we have uploaded all the slides. So if you are a speaker, you can choose your slide deck from the prepared slides as it shows here. We will try doing this. If this fails, then we can share them. But it's easier this way. You can advance the slides yourself. This is the agenda for today. Introductions, which we're doing now, document status. I'm going to talk about the joint Friday session we're having with V6 Ops in a minute. Then Eric and Suresh are going to talk about SIDS and IPv6 addressing, the output of the spring adoption call on the compression drafts. We have one working group draft we're going to do an update on. Giuseppe is going to do that. This has been in the ISG for a while, but there's been a lot of updates based on discusses from the ISG that we thought it would be good for him to go over the changes. And then there are 4 new internet drafts that will be presented. Next slide. There we go.
Should we ask if there are any comments to the agenda before we move on?
Any agenda comments? Not seeing any. So this is the agenda for the joint session with V6 Ops on Friday morning, or at least my time Friday morning, bright and early. But the general idea that generated this is that both working groups have drafts that are talking about hop-by-hop options, you know, the processing of them, the need for supporting them or not. And so after some discussion with the ADs of, you know, the internet ADs and the ops ADs, we sort of came up with this idea of having a joint session, thinking it might bring more people to the discussion, maybe particularly outside of V6 Ops and six-man. So the agenda is roughly talking about the requirements and solution drafts, and then some short talks on some current proposals for new hop-by-hop options, you know, what problem they're solving. And then just a discussion about, you know, what people think about the hop-by-hop option. You know, can we make it work better? Is there some other way of doing it? What to do with the existing options, etc. So it hopefully will be an interesting session on Friday. Any questions? Okay, next slide.
Okay, yes, so that's the document status. So we have published one RFC since the last IETF. That's 9131 on gratuitous neighbor discovery. We currently have no documents in the RFC editor queue, but we had 3 documents submitted to the IESG. To start from the bottom, the minimum path MTU option, that's with Eric in AD evaluation. But the two other drafts have gone through the IESG and have quite a few discusses and iterations. The alternate marking method we will talk about later. So Giuseppe will go through the issues he's had and the iterations and the changes that has happened through because of IESG review. The SROAM draft has essentially been in revised ID since June 2nd. It has 3 discusses and it's awaiting an update from the authors. Bob and I have been speaking to the authors and they promised us to make an update very soon now, so we'll see how that goes. We have nothing else in the queue. And also, Eric, please go ahead.
I wanted to say also that RFC 9131 was was our first document to go through the RFC editors do GitHub-based review process where all the diffs are sent by GitHub. And it was an interesting experience. I think I found it helpful, but they're still running other experiments to see how they can improve that process. So if you're an author on a document, beware that you might be able to opt into this experiment.
And it might be worthwhile perhaps that Jen and perhaps you, Eric, give a little update on that at some point, if it's just an email to the list, if there's anything noteworthy, or is the process still in flux and improving along the way? Or is this all authors will go through this now, or what's the status?
I don't know what their intent is. I think they're still experimenting. And I guess it kind of depends on the number of authors because you need to get all the authors sort of set up to use the GitHub review flow. But I found the ability to review individual diffs in GitHub much easier than reviewing lots of multi-indented text in an endless email chain with different people's email editors putting things in different fonts and different indent levels and so on and so forth. So
it looked very clean from my perspective as an observer as well, and we could probably point people to the repository that was used so people could go through and see the history as well. But
yeah, I'll go.
Yeah. Go on, Jen. We cannot hear you.
You can hear me?
Now we can hear you.
Delay. So yeah, just in a few words, I really liked it. It was easier, smooth, much easier than going through all these emails and trying to find out if I missed any comments. So yeah, I really liked it. Strongly recommend it. And it was, I don't know, it was an experiment, but it was quite simple, easy, no issues to report really. So.
Cool. Excellent. So we'll make sure that we recommend that to authors as they get to the last stage of the process. Thanks. Let's see. So document status 2. We have no documents waiting for working group adoption. We have no working group documents, and we have no documents awaiting write-up. That's not quite true. We have the hop by hop behavior document that Bob and Gori has that is awaiting being called for adoption. So I guess that's the pre-state from what we have registered here, but we'll talk about that on Friday. I think that's all. So Suresh and Eric, you are up. Do you want to share your own slides or do you want us to share them for you?
I think Eric is going to start. Let him decide.
Okay. I was going to defer to you. I have not tried this presentation.
Okay, there's a paper, scissors, rock coming up here now.
Spock.
How do I choose a slide to present? I've not had to do this.
You press the share preloaded slides button and then you pick from the list. And yours is called SIDS and addresses, I think. I'm happy to share, Eric, if you...
Oh, no, that just opened it in another window. Hang on a minute.
Yeah, do you want me to share? I can share.
Sure, there's only 3 slides anyway.
Just say next.
Okay, so I suppose this is a summary of what what has transpired in the last, I guess, maybe 3 to 3.5 weeks of some back and forth with some with the Spring on some compressed SID discussion. Next slide, please. So if you download the slides, you can click on these highlighted things. There's some links there. There is an inquiry from Spring to 6man about compressed SID behavior and some sort of SID behavior in general. There was 2 primary questions, both of which are sort of quite lengthy and detailed. Our reply was lengthy and detailed. We raised a couple of issues. One was that there was some lack of clarity around SIDs and what their semantic requirements are in certain circumstances. And we can talk about that on the next slide. There's also an issue. Oh, sorry, not. So I said, yeah. Can you go back one? Thank you. And the semantic meaning of segments left in the SRH looks like it might need to be updated, or something will have to be done to sort of update the definition, because it doesn't exactly match anymore. It's not a strict index into the. Sorry, it is treated as a strict index into the SRH, but the semantic definition is actually the list of segments left. So where the list of segments left is one-to-one mapped to 128-bit IPv6 addresses, that's fine, but that definition is now drifting. There were several other operational concerns about whether or not, about having SRH list packets, and the possibility for maybe helping SRv6 domain fail closed. If you're interested in this, I think much of this discussion will be happening on Spring. There is a way that 6man can help SRv6 domains to fail closed, and we can talk about that. And Suresh has volunteered to be the lead on the draft for us. Thank you very much, Suresh. And we're talking with other potential co-authors. So I think next slide, and over to Suresh.
Yeah, thanks, Eric. Thank you. And yeah, so thank you very much for putting your trust in me. I know this is not an easy topic, and somebody explained to me like this is like falling on a grenade. So like I do know what I'm getting myself into in this one. And I really would appreciate people in the working group helping out with a bunch of things. So what I've done is kind of gone through all the documents. I've read pretty much all the documents that are relevant to this already. So either during my ED term or after out of interest. And also I managed to go through all the mails on the 6man mailing list. I'm not sure if there's other stuff on the Spring list that is not copied onto 6man, so that's kind of my next step to do. And some really interesting comments. So thanks to everyone who commented on the mailing list. And very specifically, to call out Eric's mail was very useful, and Joel's mail, starting off this whole thing, right? With some thoughts on it, as well as Brian's mails. I found them extremely useful to kind of clarify the issues in there. So I just started putting together a grab bag of things that I think should be in this draft. Again, this is a straw man proposal. It's an individual draft, right? So I'm just throwing this up at this point. And if you feel there's something that shouldn't be in this draft, or something that should be there that I'm missing, please send a note to me, and absolutely either on list or off list, either way is fine. and we can talk about like what goes in there. So the key things I want to cover is like how do SIDs deviate from classic 4291 addresses, right? Because they don't like it kind of doesn't walk like a duck or talk like a duck, but it looks similar to a duck. And so how do we deviate them? So try to describe like how they act differently, and like some of these have like pretty clear answers, some of them don't. So I'm just throwing them all up, like because the idea is to put them in the draft and to describe like where the SIDs are assigned. Are they assigned to an interface? Are they assigned to a node? Because it makes a big difference. Like are the addresses that shows up in SIDs, are they going to be used for neighbor discovery or not? Again, big difference, like in how and they should be treated, and how do they appear to node that are SR unaware? Because I think one of the key differences for SR-v6 is like if somebody's unaware, they treat it like regular v6 packets, right? And like is there like any issues like lurking in there that we need to do? And this is another thing that came up. I think this is like a lot of these things have been kind of like knocking around for a while, and this like SID, can it appear in a source address field? That's like something that like is kind of newer that appeared in the picture. And how do we do error handling? This is like a topic that we kind of addressed like earlier, right? When we had like header insertion as an option for SRH. And one of the issues was that if somebody is doing header insertion in the middle of the network, how would like a node that doesn't know about it be able to correlate like an error packet to something it sent? So like with C says, like, is there like a similar issue that we need to handle, right? Like, how would it work for a node to identify a packet that caused an error that came from the network, right? Let's try to document that. And like this last one is like kind of pretty important that like Eric brought up, right? Like, would this require some separate v6 space, right? Like separate address space, and like a few options floating around. Like I'm not going to presuppose any numbers, but I've seen like a lot of cool names like coming up there, like for a separate address space. So if like we decide to go and do some kind of separation in the address space, like where it's not like the first 3 bits like 0 kind of thing, right? Like to see if we can like separate out these things on an address space where the semantics are expected to be different. So this is again something to explore. So this is very, very early. Like this like happened to me last week, right? Like for like a lack of a better word to describe it. So the idea is like these are the kind of grab bag of topics that I'm expecting to cover. So if you have any questions about these, or you think like I'm barking up the wrong trees or anything, just like send us a note and we'll go from there. And I started getting a few requests to co-author too. Like I'll keep you updated. But my goal is to kind of have draft out like before like end of this year, like sometime like second half of December, to have like a 0.0 version of the draft out and put it up for comment from the working group. So again, thank you very much for being patient with me. I'm asking for it in advance, so please feel free to send your comments. Thank you.
Thank you, Suresh, and also thank you to everyone who helped all of us understand what it was that we needed to understand in such a speedy time. There were lots of meetings with lots of people explaining things and handling questions. There were lots of documents circulating and people making comments and generally helping us get to some clarity on what the core issues were. So thank you to everyone who helped participate in that process.
Thanks.
Any comments from the group?
Ron, please go ahead.
6-man list, the Spring list, privately.
Sorry, repeat that. I think the first part clipped.
Would you like comments on the 6-man list, privately, on Spring list, on both?
Personally, the first 2, Ron, but like I'll also start like following Spring more closer, because I do follow 6-man all the time, and Spring like kind of on a item-based thing, but I think that's going to change. But I do prefer like 6-man and personally first, but like no worries, like if you send it on Spring too, that's fine.
Okay, thanks a lot.
Thanks.
Thank you. And then on to people joining in the microphone queue. It looks like Mitiko has a little problem with a delay so unmute yourself, wait count slowly to 3 and then you can speak. Thanks a lot, guys. Thanks, Eric and Suresh. And now, Giuseppe, you're up. Do you want to try sharing the slides yourself? Then you have full control.
Hello. Yeah, yes, I can try. Can you hear me?
We can hear
Yes.
you.
Let me also send. Okay.
That seems to be working.
Yeah.
There we are. Please go ahead.
Okay. Yeah, as also Bob and Ole anticipated, this is an update about this draft that is in ISG evaluation phase, but we did some changes in the last month, so it's better to give an update to the group. It's about the PV6 application of the alternate marking method. So in this slide, we just summarize for who is not familiar with this draft. So this is a definition, basically is the definition of a new TLV to be encoded in the options header. So it can be both an op-by-op options or a destination options. The format, the pattern of the TLV is in the figure. So the first 3 bits of the type field are all 0. This means skip if you don't recognize and data do not change in root based on the RFC 8200. And then regarding the value, we have the 2 marking fields that are the relevant bits for the alternate marking, so loss and delay bits, and then the flow monitor identification field. The operation of this option is quite simple. So the source node is the only one that writes this option header to mark the flow in both cases, in both op-by-op and destination option. In case of op-by-op option header, it can only be read by the intermediate nodes if they are configured to do so, and the measurement is op-by-op. Otherwise, if in case of destination option header, it is processed only by the destination node and the measurement is end-to-end. So this is just to recap the draft. Regarding the ISG evaluation, we got several comments and we address most of them. And yeah, this is just to summarize the most important changes, the most relevant changes. First of all, I would like to mention that the section on controlled domain has been improved in order to explain better the precondition for alternate marking application in a controlled domain. Then a new subsection to clarify the usage scenarios for the measurement domain. So we call it alternate marking measurement domain. Also, we further specify the flow monitoring identification field that must be used in combination with source and destination address in order to avoid this ambiguity, to solve this ambiguity. And then we also revised and improved the security section that now I think is quite complete. So now I'm going to describe each of these changes. So regarding the controlled domain, we clarify with a must condition that the alternate marking method must be deployed in a controlled domain. This means that it's recommended that an implementation needs to filter packets entering or leaving the controlled domain with the alternate marking data. This also solved many security concerns that were raised. We also added, as I said, a new section on measurement domain in order to clarify the usage scenarios of this methodology. This means that the measurement domain, of course, can overlap with the controlled domain or maybe a subset of the controlled domain. This is general. The typical scenario that we identified are 2. The first one is when the user equipment is the starting or ending node, but this means that the user equipment is fully managed and it belongs to the controlled domain, but this is not common of course. So the most the most likely use case that we mention is that the CPE is the starting or ending node, since it connects the user premises with the operator controller domain. It can encapsulate the received packets in an outer IPv6 header, which contains the alternate marking data. And also the CPE is also able to ensure the relevant security rules at the domain boundaries in order to filter the packets. Another clarification that we have done in the latest version is about the flow monitoring identification field. We clarify that this must only be used for flow identification purpose, for the measurement domain, of course. And also it is recommended, considering the chance of collision of this field, it is recommended that this identification field is used in combination with source and destination address to identify flow. The reason for that is because if these 20 bits are set pseudo-randomly by a node, there is a 50% chance of collision for 1,200 flows. And if we consider 1% chance of collision, we can monitor only 145 flows per host pairs. So this can be acceptable, but only if we consider source and destination address in combination with the flow monitor identification. In case of centralized control, of course, the things are much better, because with 20 bits, the number of combination is more than 1 million. And in this case, if you use it in combination with source and destination address, you can monitor 1 million flows per host pair. That I think this can cover most of the use cases. Of course, in this regard, the draft clarified that all the nodes along the path should use the same mode for identification, of course, in order to have the same identification field. Yeah, the last part is about the improvement on the security considerations. As I said, the precondition for the alternate marking application to a controller domain is the main point that helps to mitigate and confining the security concerns and the potential security issues. We added few new considerations that I have included here, but of course the security consideration now I think cover most of all the concerns that were raised, and is quite a section quite complete now. The new considerations that were added were about some cases that were raised during the DSG comments. In particular, the case where the network nodes, for example, can intentionally alter the alternate marking option for denial of service, but if the implementation is done on managed nodes, this can be mitigated at least. Also, if packets are generated outside the controller domain, may consume the resources, but this can be solved by filtering those packets at domain boundaries. Leakage also may happen, such as in case of failure or fault, but nodes outside the domain must ignore these packets, the packets with alternate marking option, since they don't have to process it. In addition, we also clarify that for specific deployment scenarios, multiple administrative domains may be traversed. But in this case, if we want to have a world controlled domain, we have to use IPsec or some VPNs to secure the interdomain links in order to build the world controlled domain. This is also another point that has been specified. In addition, it may be possible to use the marking field or the flow monitor identification field as a cover channel, but also the controller domain application helps in this case as well. Of course, the flow monitor identification is a sensitive information if it goes outside the controller domain, but the controller domain application, of course, help to solve or at least mitigate this issue as well. Yeah, the summary. So I think that most of the concerns are addressed in the latest version. So maybe some needs is still missing. I don't know. The latest pending point that is relevant is about the informative reference to experimental RFC 8321 and 8889. As you may recall, we had a discussion on this in 6 months mailing list, and we say that downref in this case can work if we include in our draft the detailed description of the methodologies. The current version includes the detailed description of the methodology, but we still have some discussed positions about the proposal to elevate RFC 8321 and RFC 8889 to standard track, since they are now experimental. So let's see if this is a blocking issue to progress this document. So we are waiting for the next ASG review in order to understand if some discussed positions can be solved or not, or if we really need to this document to overcome this issue. So that's all for me. So if you have questions, comments, and thank you.
Thank you, Giuseppe. It sounds like there's enough hurdles, but at least we're making progress, and we'll follow up on the discussions, and let's hope we can sort those out. Any comments? No, we'll work with Eric, our AD, as well on these discussions, and let's hope it probably won't be this year, but hopefully next year we'll have
hopefully it won't.
this one.
Hopefully it won't take too long.
Thanks a lot, Giuseppe.
Okay, thank you again.
Let's see, so where are we now? So now we have a set of new individual internet drafts. The first one is carrying VTN identifier. Jidong, please go ahead. Grant you access. The floor is yours.
Yeah, can you see my slides now?
Yes.
See and hear you. Well,
Okay.
slides at least.
Hello everyone, this is Jiedong, and I'm going to give an update about this draft on the carrying VTN identifier in the IPv6 extension header. Okay, here are some background information. I will go through it briefly. Basically, we are proposing to produce an enhanced VPN service to meet the customers' requirements in the 5G and other network scenarios which require connectivity services with advanced characteristics. And for this, we introduced a concept called VTN, which is a virtual underlay network consisting of a set of dedicated or shared net resources, and is associated with a customized topology. It can be used as a virtual underlay to deliver one or a group of VPN plus services. Further, we need an identifier of the VTN in the packet so that it can be passed by each hop along the forwarding path to steer the packets to use the set of resources allocated to the VTN for the packet processing. In this document, we propose the mechanism to carry the VTN information in the IPv6 hop-by-hop extension header. Here is the proposed new option type to carry the VTN identifier and information in the hop-by-hop extension header. Basically, it contains a 4-octet identifier, which is used to uniquely identify the set of network resources allocated to the VTN. And its length is to match with the network slice identifier defined in the 3GPP for 5G. Here are the procedures to process this information on the edge node and the transit nodes. On the ingress node, it is based on the classification and mapping policy of the operator. It will determine how the packet should be mapped to a VTN and to encapsulate outer IPv6 header together with the VTN option in the hop-by-hop header, which contains the identifier of the VTN resource the packet is mapped to. Then on each node along the packet path, the IPv6 destination address is used to determine the next hop and outgoing interface. The VTN resource ID in the VTN option is used to further determine the set of resources allocated on the outgoing interface for the packet processing. With this, the traffic class may be used to further provide div serve treatment for packets in the same VTN. At the edge node of this IPv6 domain, it should decapsulate the outer IPv6 header and the VTN option in the hop-by-hop header. In this version, we resolved some received comments after last IETF meeting and also offline. The first comment is VTN ID used to determine the path or the resource? The resolution in the draft is the term has been changed to the VTN resource ID to avoid the confusion, and we clarify that its function is to determine the set of local resources. The second comment we received is to suggest to add some text about the relationship between the VTN and the topology control mechanisms, so that we update draft with some text to describe the mechanisms used to specify the VTN topology. The third comment is to suggest to add brief introduction about the background of VPN, VPN plus, VTN, so that we add an introduction about these concepts in the abstract, also in the introduction. So for the next steps, because we think this document proposed to use the hop-by-hop as an extension header to carry a new option type for the hop forwarding treatment, and which is, I believe, is a suitable approach for this application scenario. And based on recent discussion and the revisions, the content of the document has been stable. So the authors would like to request the working group adoption on this document. That's all. Thank you.
Group.
Thank you. Any comments? So G has asked us if we should put this draft out for an adoption call. Was a little unsure of the interest in the working group. So I wonder if we should run a quick poll on this one. So if you're interested in working on this draft, could you please raise your hand? And if you're not interested, press the do not raise hand button. Just give that a few more seconds, and the next one up is Xiao Min with IPv6 extensions for IOAM capabilities. So about 37 hands, there's or 38 hands, there are 27 hands down and 11 people who've raised their hand. So we'll end that one. 40 hands, and there's 30 in the who are keeping their hands well in their pockets.
The 11 seems to be stable.
Yes. And I think at least I can see the results. I'll copy those for the minutes. I don't know if everyone else can see them. Okay, excellent. Thank you, G.
Thank you.
Okay, Qiao, the floor is yours. Do you want to share the slides yourself? Excellent. Thank you. Please go ahead.
Okay. Okay, thank you. Hello, everyone. It's Xiaoming speaking. This presentation is on ICMPv6 echo request reply for enabled in situ OAM capabilities. This is a 0.0 version individual draft. This is the background of this draft. Draft IETF IPPM IOAM conf state defines a general method of IOAM capabilities discovery, including IOAM capabilities formats. In that draft, echo request reply is used for IOAM capabilities discovery, through which the IOM encapsulating node can discover the IOM capabilities of each IOM transistor and decapsulating node along the transport path of data packet.
Excuse me, Xiao, is there anything, your audio is clipping quite a lot. Is there anything you could do to remedy that, you think?
Oh, I don't know what's the issue, but
it breaks
I
off every 3-4 seconds. If you like, we could put you at the end and let the other presenters go and see if you could figure it out, because it was very disturbing for the presentation, I think.
Okay, that's fine. That's fine.
Okay.
Okay.
Yeah. Let's retry, and then we'll jump to the next and come back to you. Thank you.
Okay.
Okay. So, Vasilenko, do you have your slides ready, and then we can?
So probably yes. Do you hear me?
We can hear you fine.
Okay.
I'll grant you access to the floor.
Yeah, thank you. I need to find my slide deck. Yeah, here.
Excellent. Go ahead.
Okay. Okay, fine. We have middle-size update from the last presentation, but the last presentation was extremely short because it was late. For that reason, probably this time I will speak like it's first time, because it's really probably really the case. Okay, the background is probably very similar, which was already discussed many times in 6 minutes about flash renumbering, because primarily the use cases are taken from flash renumbering, which is already RFC from V6 Ops to solve the problem. But there is one big difference. The big difference that we did try to address here, not just the cases which has been discussed in flash renumbering, but additionally multi-hop, multi-prefix, because in the situation that we have multi-hop, multi-prefix, we have even bigger challenge for a situation when flash renumbering will happen, then some prefix will change, and we have a problem even for the case then the prefix will not change, but even in the stable multi-hop, multi-prefix environment we have a problem, and we have found ways how to address. Just maybe one disclaimer that we did not try to solve anything after first hop. I mean, here we discuss only neighbor discovery protocol. Of course, for proper operation of multi-hop, multi-prefix, you need more. You need next step between routers probably on the side. You need something like source routing, which we do not discuss here. We are concentrated only on the first hop problem. Okay, this slide I will tell very short because it's a regional problem which has been brought to the six ops to 6-man initially, and which is discussed in 8978. It's the situation then the router will reload or the uplink will be reestablished to telco, and after this, if it would be new prefix and if the router will coincide with this, will be different from the switch. Separate device, then it may be that the previous prefix will not be properly deprecated, but the new one will be announced, and of course host could use both, and if host will use old one which is not available anymore, of course it will create a problem. It's well-known problem which I probably don't need to stress too much. Maybe a little bit new thing, we have here 3 cases, 1, 2, 3, because the case number 3 is really new one. Loba has told us that it's a new one case from our third author. It's a situation when, for example, the box will be disconnected, power disconnected, and would be replaced, physically replaced. And after a load, of course, it will have different flash memory, different MAC address, and it will look like different router. It's a little bit more complicated problem, but it's okay, could be very similar to flash renumbering. The second case, again, a little bit discussed, maybe not as much as in this particular draft, but it's discussed already in 8978, that could be the situation that if some particular management system will change something abruptly without proper deprecation, especially hard situation if VLAN will be changed on the switch, then the host will be connected to different VLAN, effectively different subnet. And if it's different subnet, of course, prefix would be different, and the previous one would not be deprecated. Its router in this situation could do nothing, because if VLAN will change very fast, it's not possible to react. The situation then some configuration, maybe even prefix would be changed on the router is possible too, but it's if NMS or SDN or whatever not developed properly. If it's a really abrupt change, then again it could change, and then the host will have 2 prefixes, and of course host could choose the wrong one. This is a really new slide compared to RFC 8978, because here is a discussion that could be the situation then particular site has connection maybe by different routers, connection maybe couple of connections, maybe 1 connection to different carriers, typical multi-hop, multi-prefix, and in this situation 2 things should happen properly. One thing, initially the host should choose proper source address, because if the host will not choose proper source address, then it would not possible to reach, for example, Wallet Garden in one particular telco. And then after source address properly chosen, then should be forwarded to proper destination, to proper next hop. Initially, next hop should be proper one on the first hop link, and then of course it should be proper one between routers if site has many routers. But this one, with one discussion about how to do source routing between routers is out of the scope. Here is only the first hop in the scope. These two stages to choose proper source address and to choose proper next hop for the host is discussed in this particular draft, in the 2 situations, in a normal situation and in the situation then particular uplink, for example, is down. It's a more or less complicated discussion. It's a big section in this particular draft. Okay, effectively we have here about 7 problems. And for 7 problems, we have some number of solutions, 9 overall, because some particular solutions is solutions for a few cases. Effectively, it's multi-hop support, basic multi-hop support from the first hop point of view. Situation when in multi-hop environment, one particular link, one particular router is down. Abrupt configuration change is something that change not gracefully. If the previous prefix is not deprecated for any reason, and some number of reasons is discussed what it could be, why it could be not graceful. Could be, of course, power outage. Could be abrupt router outage, because in home environment people typically try to fix any problem by disconnect power, reconnect power. It's a typical behavior of every subscriber. For that reason, it's more or less typical situation than home gateway CPE. Home gateway with power cycle is more or less normal situation. A little bit, maybe small discussion on the situation, then link local address of the router itself is changed. It may be by configuration, and there is discussion what to do. And there are some number of more or less simple modifications which is proposed to standard. But okay, every modification is by itself is maybe simple, but because overall is 9 modifications, it overall may be complex, because maybe some permutation, maybe some influence from one particular modification to another. Almost all modifications related to ND protocol, to both drafts, to both RFC, ND, and SLAC, and only one is related to CPE requirements, where we have recommendation to change current practice, because current practice, which is not suitable for multi-hop, multi-prefix environment, current practice, if some particular uplink or some particular prefix route to the carrier is lost, some particular prefix is lost, then the current recommendation is to have to cancel default routers, to deprecate default routers status, but it's not possible. It does not work properly for multi-hop, multi-prefix environment. For that reason, we change it to recommendation to deprecate prefixes. It's not just us. We have seen it, for example, from HomeNet. For example, they have the same modification. In reality, draft is more or less big, because nine solutions, and for 7 problems, 7 technical problems, nine technical solutions is more or less big document. As a result, we invite everybody for participation in discussion about this draft, or about. We believe we have found all situations, not just flash renumbering, which is already discussed in RFC, but we have found all other situations. Then some particular ND protocol information could become stale. Effectively, it's like we stated in the name, it's ND robustness. It's how to fix all stale situation when information is stale in ND protocol. That's it. Questions?
Thank you. Quite a lot of comments on the chat. So if someone want to represent the view from there, step up to the microphone queue. You're welcome. Jen, please go ahead.
Oh, sir, I'm a bit confused here, because we just discussed it on the chat. Hosts which support Rule 5.5 of default address selections, which is RFC 8028, right, will be basically not really affected by like sudden router replacement, right? So I'm not sure we really need to tweak ND too much. We already have a solution for most of those problems. It's just host implementations do not care. So maybe we need to like focus on this part.
We believe no, that it's not the case. Yes, really, 8028, RFC 8028 has a good recommendation, but it's general without details how to properly achieve this. For that reason, yes, this particular RFC formally should resolve multi-hop, multi-prefix situation, but in reality it is not resolved, because not enough detailization what should be really changed in ND protocol. It's just a good guidance, a good direction, not the detailed explanation what to do.
No, wait, sorry, I think it's not about changing ND protocol, it's about host using binding next hop with a source address, right? And it's already basically Rule 5.5 of default address selection. Unfortunately, yes, there are not so many implementations on the host side yet, but it's again the chicken and egg problem. Hosts, there is no probably use cases yet for multi-home IPv6 networks, so that's why we do not see it in like real life. So I don't think it's an ND problem. I think it's a host implementation problem from address selection perspective.
But this host selection is anyway related to ND, because you should have you should do two things. You should to properly choose source address and properly choose next hop, two stages. RFC 8028 gives a general recommendation how to it's really good recommendation. We follow it, by the way. We don't contradict to this recommendation, just we have more details. But in reality, we follow this particular recommendation how to properly choose source address. How much is it enough? We believe is not, because probably some more details is needed, but maybe it's discussable. Maybe I'm wrong here.
Any
Sounds
other
like
comments in the room?
if not, it sounds like something we need to continue to discuss on the mailing list.
Yeah, I mean, and I'll add that my take is I think there needs to be some agreement on the problems before spending a lot of time on the possible solutions, and see if you can build a consensus on the list for that there's some problems that need to be solved that we don't currently solve in other mechanisms.
Well, thank you, Edward. Then we have Fred Templin on V6 fragment retransmission. Do you want to share the slides, Fred? I can hear you, Fred.
Okay, I'm going to try to share the slides. Give me a moment. Okay,
there you are.
We have
Go
the slides
ahead.
now, I suppose, right? I'll even give video. Okay.
Good, go ahead.
Okay, IPv6 fragment retransmission. This is a new draft. It's a new draft, but it's a very, very, very old subject. And it's something that's been known for about 35 years. And the motivation, which is the big picture for this whole talk, is that some applications see greater performance by sending IPv6 packets that are larger than the path MTU. Some examples are NFS over UDP, which has been known since the 1980s. LTP, which is the DTN Licklider Transmission Protocol over UDP. I have a question mark after QUIC because I really haven't had time to investigate QUIC, but since QUIC uses UDP, it also could potentially see better performance by using IPv6 fragmentation. And then also finally, IPv6 tunnels. Now this is readily demonstrated with iPerf3. If you were to put together two Ubuntu laptops over an arbitrary network and use iPerf3, you'll see better performance by sending packets that are larger than the path MTU than you'll see by sending smaller packets. Now, when a source fragments an IPv6 packet that's larger than the path MTU, we have the problem that the loss unit, which is an individual fragment, is smaller than the retransmission unit, the entire packet. So for example, if a 64 KB packet was sent in fragments of 1280 bytes, and one of those fragments was lost, you'd have a retransmission storm of 64 1280 byte fragments, when you would really only prefer to retransmit just the one that was lost. So the objective is to, when possible, retransmit individual fragments to make the loss unit to be equal to the retransmission unit. So how does IPv6 fragmentation work? Well, there's a fragment header that includes an 8-bit reserve field, which is set to 0 on transmission and ignored on reception. The source is now going to be using this reserve field to encode a fragment ordinal value plus a retransmission supported indication bit. The destination is going to maintain a per packet ordinal checklist, and it will request retransmission of any missing ordinals that don't arrive. By doing so, the destination sends a new ICMPv6 fragmentation report message, fragrep. The source retransmits any missing fragments if possible. Now, this model is modeled after the link layer automatic repeat request facility that's been described in RFC 3366. It's fast and efficient, and it often, but not always, often avoids slow and expensive end-to-end retransmissions. So how does the RFC 8200 IPv6 fragment header currently look? It's as you see here, it has the reserve field, the fragment offset, identification, and so forth. What this document is asking is to update RFC 8200 to remove the reserve field and in its place put an ordinal field, which is a 6-bit ordinal number, a reserve bit, and an A bit for ARQ supported. And when A is set to 1, the ordinal is going to include a code of value between 0 and 63, which is the ordinal fragment number. So then we have now this new ICMPv6 fragmentation report message. The new message is going to include N identification, comma, ordinal bitmap list entries, each one of these entries being 12 octets long. So the number of entries is limited by the minimum IPv6 path MTU of 1280, meaning you can get, actually the number is 103 list entries maximum per ICMPv6 message. And if you need to send more, you just simply send more fragrep messages. The destination includes N fragrep list entries with 32-bit identification followed by a 64-bit ordinal bitmap. So for each identification, the receiver is going to examine the ordinal bitmap bit I. If I is 1, it means the fragment with the ordinal value I was received. If I was 0, it means no fragment with ordinal fragment value I was received. So that when the source receives the fragrep, it can retransmit either each per identification fragment where the ordinal bitmap of I is 0 if the fragment is still in its cache. And then the source finally discards the fragrep after all the list entries have been processed. So some additional considerations. The 6-bit ordinal bitmap plus the 64-bit bitmap limits the ARQ to only the first 64 fragments. That means that if there were any additional fragments beyond the first 64, they would be sent best effort, the same as the current practice. The largest IPv6 packet that can undergo fragmentation is 64K, and the minimum MTU is 1280 bytes. So normally, 64 fragments would be more than enough to accommodate even the largest IPv6 fragmented packet. However, IPv6 fragments sometimes traverse IPv4 networks, for example, by tunneling them over a IPv4 network, where there may be a smaller minimum MTU. In that case, there may be more than 64 fragments needed to traverse IPv4 networks. So that means that the source is going to need some form of soft packet to big message to be sent back to the originator so that the originator will reduce the size of future packets. And this is especially important when the source is an IPv6 tunnel ingress. So an ICMPv6 packet to big soft error is indicated by setting the code field of the message to a non-zero value. The IPv6 tunnel ingress would both forward the packet using IPv6 fragmentation and at the same time return an ICMPv6 soft error. The original source would receive the soft error and reduce the size of future packets while the original packet will likely arrive at the final destination. So that this is a lossless path MTU discovery. So the ICMPv6 packet to big soft errors provide dynamic feedback so the original source can tune the packet sizes it's sending to ensure optimum performance with little or no loss. Lossless path MTU discovery. So since we're going to be now embracing fragmentation, we have to ask the question of whether an additional integrity check is necessary. Well, each IPv6 fragment will undergo link layer CRCs on the path, as well as transport layer checksums at the final destination following reassembly. So for pure IPv6 paths, this is already probably enough because IPv6 fragmentation includes a 32-bit identification number, and it also includes other reassembly safeguards such as non-overlapping fragments. But for IPv4 paths, or mixed IPv6 IPv4 paths. IPv4 fragmentation only includes a 16-bit identification, and it has no safeguards against reassembly errors, so that reassembly errors are possible. So for this reason, IPv6 fragments that might be ported over an IPv4 network require an additional integrity check inserted by the IPv6 tunnel ingress and verified by the IPv6 tunnel egress. Very important point. Integrity is important. And that's really the end of the presentation. This is the name of the draft, and I think I'd like to seek whether we can bring this in as a 6-man working group item.
Comments from the working group, please? Not everyone at once.
We could do a poll of the room to see if there is any interest in working on this in 6-man, if you think that's a good idea.
I'd just like to reiterate the most important chart is chart number 2 in this deck, which gives the big picture. And that big picture is the fact that we're missing something in the internet today. And that's the fact that we could be leveraging IP fragmentation to get better performance than we can get without it.
So Fred, do you see that as an inherent quality of the IP fragmentation, or is it an artifact of implementation or the particular segmentation and reassembly that is done on upper layers for these particular applications?
What makes it faster is that when you send a large packet from the application, you make a single system call. And when that packet hits the operating system kernel, the kernel then calls IP fragmentation, which sends the packet as a series as a burst of fragments. And when that burst occurs, you get very high network utilization. So it's that bursty nature of sending one large packet and getting potentially as many as 64 fragments in a rapid fire burst that causes you to get greater network utilization for that time period. So it's a savings in systems calls, it's a savings in interrupts, and it's making greater network utilization by leveraging these fragmentation bursts.
So these bursts have a tendency to be capped by network devices in the network too. But yes, okay. So this is sort of some of the problems that TSL1 hosts have tried to solve, I suppose.
Yeah, I mean, there's a lot of discussion in the chat room, but I mean, there's also, I think, a bunch of hard interactions with transport protocols, which are also doing retransmissions, and it gets really messy when if you had the IP layer doing fragment retransmissions, and the transport protocol doing its own retransmissions, and I think this is.
Bob, let me stop you for just a second, if I could. That's not really correct. The model is RFC 3366, which is link layer IRQ, which is an imperfect but timely retransmission to not interfere with the perfect end-to-end retransmissions that might be necessary if the fragments can't be replaced.
Well,
Eric,
the way,
sorry.
yeah. Let me just, and then we'll go to Eric. Of course, in IPv6, since it's the source who's doing the fragmentation, not an intermediate node, it's very close to end. But
not necessarily if the source is a tunnel. If the source is a tunnel endpoint, the original source could be far away from it.
That is true. So Eric?
Let me wait my customary 17 seconds for audio sync up. As an individual contributor, speaking as an individual rather, are some of these things separable? For example, specifically the PTB software. Is there something useful or valuable in just the PTP in the softwares, and possibly using that to update, say, a higher layer TCP MSS or something in advance of it discovering that it needs to do packetization layer FMT discovery or something?
There's definitely more there when it comes to the packets of big software than what I'm just giving in this presentation, and it's probably worthy of another draft of its own. But this is all discussed in detail in the Arrow and Omni drafts, how packet to big softwares are used. And in this case, the tunnel endpoint source can send the packet to big softwares, but the tunnel endpoint egress could also send packet to big softwares, for example, if it's having reassembly problems. So there's more there. Yes, you're right, Eric.
Yeah, I'm wondering, if it's separable into smaller, yet still useful chunks. Basically, thank you.
I think that's a good point.
Any other comments? Okay, thank you, Fred.
Thank you.
Thank you. And we had 12 people raising their hand and 24 people who kept their hands in their pockets. Okay, so for the last presentation, we'll try again with Xiao. If you have fixed your audio now, ICMPv6 extensions for IOM capabilities, please go ahead.
Okay. Can you hear me now?
We can hear you now.
Is my audio better?
It sounds much better.
Okay,
Fingers crossed.
thank you. I changed to a new laptop, and I'm sorry for the inconvenience.
That's okay. Do you want to share the slides? Yes.
Yeah, I can try. Okay. Hello, everyone. It's Xiaomi again. This presentation is on ICMPv6 echo request reply for enabled in-situ OEM capabilities. This is a 0.0 version individual draft. This is the background of this draft. Draft IETF IPPM IOM conf state defines a general method of IOM capabilities discovery, including IOM capabilities formats. In that draft, echo request reply is used for IOM capabilities discovery, through which the IOM encapsulating node can discover the IOM capabilities of each IOM transit and decapsulating node along the transport path of data packet. This draft is a companion document of that IPPM document. Specifically, this draft defines ICMPv6 extensions to achieve IOM capabilities discovery in IPv6 networks. This slide shows the newly defined ICMPv6 IOM echo request reply messages, taking example by RFC 8335. This draft requests two new ICMPv6 type numbers from IANA, one for IOM echo request, another for IOM echo reply. The upper figure is the format of ICMPv6 IOM echo request message. The two fields in the red ellipses are defined in this draft. They are the number of IOM namespace IDs and a list of namespace IDs. Number of namespace IDs is a 8-bit field. That means at most 256 namespace IDs can be carried. 256 is treated as a big enough number. Each namespace ID carried within the list of namespace IDs is a 16-bit field. At least one namespace ID would be carried. The lower figure is the format of the ICMPv6 ILAM echo reply message. The field of number of namespace IDs in echo reply message would be no bigger than the same field in the echo request message. A list of objects is carried in the echo reply message. Each object represents one type of IOM capabilities in one namespace ID. This is the first type of ICMPv6 object defined in this draft. It's called ICMPv6 IOAM pre-allocated tracing capabilities object. This figure is the format of this type of object. Each ICMPv6 object is composed of the object header and the object payload. The object header includes 3 fields. They are length, class number, and C type. The combination of class number and C type indicates type of this object. Among them, a new class number indicates IOM tracing capabilities object. And the C type 1 indicates that's pre-allocated tracing. Another type of IOM tracing is incremental tracing. The object payload includes IOM trace type, namespace ID, egress MTU, and egress interface ID. And one more W bit is used to indicate short format or wide format of egress interface ID. Among them, the IOM trace type is a bitmap that indicates what kinds of tracing data are supported by the echo reply sending node. Note that the whole object payload is not defined in this 6-man document, but defined in that companion IPPM document. The reason is to avoid repeated definition of the same object payload for all different kinds of ping, such like ICMPv6, MPLS SP ping, SFC ping, and beer ping. This is the second type of ICMPv6 object defined in this draft. It's called ICMPv6 ILAM incremental tracing capabilities object. This figure is the format of this object. It's also composed of the object header and the object payload. The combination of class number and the C type in the object header indicates type of this object. Among them, a new class number indicates IOM tracing capabilities object, and the C type 2 indicates that it's incremental tracing. The object payload of this object is also defined in that IPPM document. This is the third type of ICMPv6 object defined in this draft. It's called ICMPv6 IOM Proof of Transit Capabilities Object. This figure is the format of this object. The combination of class number and C type in the object header indicates type of this object. Among them, a new class number indicates IOM Proof of Transit Capabilities object, and the C type is set to 0 at transmission and ignored at reception. The object payload is also defined in that IPPM document. This is the fourth type of ICMP object, ICMPv6 object defined in this draft. It's called ICMPv6 IOM edge-to-edge capabilities object. This figure is the format of this object. The combination of class number and the C type in the object header indicates type of this object. Among them, a new class number indicates IOM edge-to-edge capabilities object, and the C type is set to 0 at transmission and ignored at reception. The object payload is also defined in that IPPM document. This is the fifth type of ICMPv6 object defined in this draft. It's called ICMPv6 ILAM DEX, Direct Export Capabilities Object. This figure is the format of this object. The combination of class number and the C type in this object header indicates type of this object. Among them, a new class number indicates IOM DEX capabilities object, and the C type is set to 0 at transmission and ignored at reception. The object payload is also defined in that IPPM document. And this is the last one, the sixth type of ICMPv6 object defined in this draft. It's called ICMPv6 IOM end of domain object. This figure is the format of this object, and the combination of class number and the C type is used to indicate type of this object. Among them, a new class number indicates IOM end of domain object. C type is set to 0 at transmission and ignored at the reception. And the object payload is also defined in that companion IPPM document. This slide demonstrates the security issues mitigation methods described in this draft. First one is suggested to use IP authentication header or IP encapsulating security payload header to provide integrity protection for IOM capabilities information. Second one is suggested to use IP encapsulating security payload header to provide the privacy protection for IOM capabilities information. Third one, the network operators are suggested to establish policies that restrict access to ICMPv6 IOM echo functionality. The policies include enable, disable ICMPv6 IOM echo functionality, define enabled namespace IDs, and for each enabled namespace ID, define the prefixes from which ICMPv6 IOM echo request message are permitted. The fourth one is suggested to rate limit incoming ICMPv6 IOM echo request message. Next steps for this draft, we authors ask for more reviews and comments. We revise this draft to improve it. And then we may ask for working group adoption. Thank you.
Chen Li, you are the head of the queue. Please go ahead.
Questions about this extension, like I proposed before in IPPM working group. First of all, is that can a host outside the domain to send an ICMP probability packet to trigger the, how say, IOM capability information? Can we?
Do you mean the host? The IOM
Yeah.
encapsulating node as a host? Yes. If the host is the IOM encapsulating node, then the host can send ICMPv6 echo request to query the IOM capabilities from the IOM transit node and the decapsulating node.
Yeah, like what if I am a attacker, right? I'm a hacker, and I send a lot of like DDoS packets, probability packets to to get the IOM information from your network, so I can send thousands of packets to a node. And you are saying that we can use like IPsec, for example, AH or ESP for security. But the thing is that if you want to provide this kind of protection, you have provide a full mesh IPsec connection in your network. Is it possible? Because you need to ping any node in your domain, right?
This draft provides some security issues mitigation methods. You can see in the slide. Not just
I can see it.
Yeah, not just use IP authentication header, IP encapsulating security payload header. You can also ask network operators establish policies that restrict access to this functionality. You can also rate limit incoming ICMPv6 IOM echo request. So you have some methods to mitigate the security issues.
Yeah, sure. But as you know that in the real network, the IPsec is really heavy, or it's really hard for implementation and usage, right? It's really hard for deployment. And in order to protect the IOM capability, we need to build up full mesh any-to-any IPsec connection in the network. I don't believe that would be the real deployment. So that is my comment. And yes, you can use some rate limitation method for protection for protecting DDoS attack. I agree with that. Yep.
IPsec is not a must.
It's not a must.
Okay, we have a number of other people in the queue.
Okay,
we go through
that's
them.
it. Thank you.
Thank you. Edward?
I have a question. I have not understood, is it hop by hop or end-to-end? Because IOM typically is useful when it's implemented hop by hop, then you could understand which particular hop is a problem. But looks like if it's ICMP, then the packet could go only end-to-end. And in this situation, how much it would be useful if it's not hop by hop? Do I understand something wrong or what?
Okay, let me explain. In this job, ICMPv6 echo request is not just for end-to-end. It can be sent to the IOM transit node along the path. So every transit node can receive an ICMPv6 echo request and send a reply to the IOM encapsulating node. So that's also for hop by hop.
Okay, separate probe, like trace route, separate probe for separate hop. Okay, understood.
Thank you.
Okay, Eric with a C.
About this draft, it relies basically on IPPPM draft. Can you tell us a few words about the status of those drafts? Are they adopted? Are they working group last call or?
It's adopted this year in July this year. It's now a 01 working group draft.
Okay, thank you.
Thank you.
And Eric.
I'm curious to know how large do you think these messages are going to be, and whether or not you think they might exceed the MTU of the operator network. I don't know how much information is the complete list
yes.
of namespaces is going to be.
Yes, for the echo request, I think the message will not be too big, and for the echo reply, the message, the size of the message may exceed the MTU limit. So in this draft, we have a code for the big message, echo reply message that exceeds the IPv6 MTU limit.
Oh, yeah, like you have a truncation flag kind of thing, or you just go ahead and send the super large reply.
I can see. This one for the IOM echo reply message, there is a field code field, and if the message is too big, exceed the limit of the IPv6 MTU limit, one code value can be set to tell the IOM encapsulation node that this message is too big, and all the objects will be stripped.
Interesting. Thank you. Curious.
Thank you.
Okay, thank you. At least my take is I think this needs more discussion, and I think we would like to also hear from the IPPPM working group as to how this fits into what they're doing or not. I personally don't have any objections to more ICMP messages, but it needs to fit into a larger use case, I think. But let's continue discussing on the list. Thank you.
Thank you, Bob.
Well, good. So I think we are done for today.
See you all on Friday.
Or hear you or something. See you in the queue on the Friday session. So have a good IETF week. I think we are done.